So yes, when we solve logarithmic equations, what's inside the log cannot be negative or zero. Because if we took log base b of 0 equals c as an exponential, we would say b to what power is 0? Well, if c is a positive number, if we just went up from greater than 1, well, that's just going to make it bigger. It's not going to be 0. If c is 1, well, if b is 0, b to the 0 is just 1. B to the first is b. And if we said b was a negative number, so say negative 2, well, that's going to be 1 over b squared. Well, that's just going to make a big fraction. It's not going to actually be 0. And in all three cases, none of these are negative. So we can't have a negative in here. If we have a negative log of a negative number, it doesn't work. So those values of x, when we plugged it back in, if it gave us a negative inside the log, so we plugged it, or for this here, if we plugged this one back in, here we'd have the natural log of negative 2.36. I can't have natural log or log of that negative, so it doesn't work. But on the one we did for the homework here, when we plug negative 1 back in, so here we plug negative 1 back in, we squared it, it became positive. Because what we're wanting to make sure is the numbers in those two spots are not 0 or negatives. Because if they are, then it's a restriction, it's an extraneous solution, we throw it out. So, all right, guys. So, what we're looking at today, the last section of chapter 6, is inequalities. Solving inequalities has three main steps. We get one term on either side. We get the variable out of the power or log. Solve, which has been the same three steps. So the inequality sign will stay there. Now we do have one term on either side. So we can apply the log to both sides. Now to help this and help us solve this here, make it a little bit nicer, since the variable is only on one side, we can take log base 3 of both sides. Because taking the logarithm, our properties of logarithms, says that we can move the variable to the front. Questions on this so far? Well, log base 3 of 3 is 1. The only time we'd have to flip that inequality sign is if we're multiplying or dividing by a negative. If we multiply or divide by a negative, we have to flip it. And that's it. Now, the nice thing with if we're solving an exponential, since the variable started in the exponent, there are no restrictions for what x can be. X can be positive, it can be negative, it can be fractional, rational, irrational. That's our answer. The only ones we have restrictions are when we're going to solve logarithms.
Don't do it.
So let's look at the next one. E to the x is less than 2. Yes. We have one term on either side, and the log we're going to apply to both is going to be the natural log. And the reason we use the natural log is the natural log's base is e. So we have ln base e of e, so that will simplify. We move the x to the front. Telling us that we have x times the natural log of e is less than the natural log of 2. Natural log of e is 1. So 1 times x is just x is less than the natural log of. Yes. Yes. Questions on these here? 10 to the 2x minus 6 is greater than 3. 10 to the 2x minus 6 is greater than 3. Do we have one term on either side? Oh yeah, we have 10 on one. Even though that we have the 2x minus 6, it's on the exponent. So that's fine. 3 is by itself. I guess. So we can apply log to both sides. What base would we want this log to be? 10, yes? Well, if I don't write the base, it's understood to be 10. So we don't actually have to write the base. Log is base 10. Log of 10 is going to reduce to 1, and our 1 times 2x minus 6 is going to be 2x minus 6. Is greater than log of 3. Since x is not by itself, we just need to get x by itself. So the first thing we can do is add 6. And then the last thing we would need to do is to divide by 2. It would not. The 6 and 2 won't simplify because of the log 3. If we had, say, 2 log of 3 plus 6, then we have a common factor of 2 on both terms on top and bottom. That plus 6, log of 3 plus 6, this one term prevents us from just dividing one of them by 2 because they're stuck together. And that's it. So the nice thing with the exponents, where the variable starts in the exponent first, we don't have to check anything. We don't have to check restrictions to make sure the numbers work. Yes. Questions on this here? We feel good with this here. All right. What we're going to look at next is logs. So this is the next part, logs. So we've gone over solving exponentials. Now logarithms have one little difference to them. And we talked about this is that what's inside the logarithm, its value cannot be negative or 0. So if what's inside the log is negative or 0, whatever value or solution we had, we have to throw it out. Now it's a little bit different with inequalities because we have a range of solutions. So for us here, we do have restrictions. Now the restrictions, so if we look what's inside the logarithm, and for us here, that would just be the expression x. And we take that expression, whatever's inside the log here, and set it less than or equal to 0, then solve for x. Well, here it's just already solved for us. So any value of x that is less than or equal to 0 would be a part of the restrictions, because it would cause us to have 0 or a negative number inside the log. So for us here, x cannot be less than or equal to 0. Now the restrictions may or may not come back into play. We just put them there so we know what they are. And if they are a part of the solution, we remove them. So the base, I think is what you're asking, yes? If the base is not written, it's understood to be 10. So we put both to the base of 10. Because here, 10 and the log base 10 will cancel, giving us x is less than or equal to 10 to the second power, or yes, 100. So we solved that there, yes? So we said x cannot be less than or equal to 0. Someone give me a value, or one of the restrictions that we would have. -8, -2, yes? These are both restrictions. So let's see here, is -2 less than or equal to 100? Yes, -2 is less than or equal to 100. That's true. -8, is it less than or equal to 100? So what that tells us is that our restrictions are included in our answer. We cannot have those in our answer. So what did we say x could not be? Zero is less than x is less than or equal to 100. We had to take that restriction, the fact that x could not be less than 0, and put it as part of our answer. Now, if they weren't included, -2 was say greater than 100. That's not true. If they're not included, we don't even have to worry about the restrictions because they're not a part of the solution. So just that's it. But here, since they were, we had to add the fact that 0 is less than x to make sure any value that was a restriction was removed from the solution. And that's it. Be ready for the next one. Log x plus 9 is less than 45. So what is inside the log? And that's exactly why I asked this, because mathematics, it is assumed if there are no parentheses, the parentheses go right there. I think it's dumb, because if it doesn't take that much to put a set of parentheses. And if it's not written, if the parentheses are not written, anything that's added after the log is considered outside the logarithm. Restrictions. Well, again, the only thing inside the log is x. And we know that it cannot be less than or equal to 0, or we could say that x has to be what? Greater than 0. Either way, x cannot be less than 0, x can be greater than 0. And that's it. So we know that x has to be bigger than 0. Do we have one term on either side? No. We got to move that 9 over. Telling us that log of x is less than 36. Okay. Our next step would be to what? Put both sides to the base of 10. Yes. This will tell us that x is less than 10 to the 36th power.
It's writing the actual answer.
You do not have to write that. 10 to the 36 is, yeah. 10 to the 36 is 1 with 36 zeros. Again, that's, as I said yesterday, if we get a number to a power that's just way too big, this is one of those cases. We're leaving it as 10 to the 36. Let's just use the same ones. -2 and -8 are restrictions. They would cause us to have a negative inside the log, yes? Is -2 less than 10 to the 36? Yeah, -8. So those are a part of our solutions, but they are restrictions, which means that we have to add the fact that 0 is less than x is less than 10 to the 36th power. Questions on any of this here? Ready to the next one. What? For this one here, I'm going to change it a little bit. I'm going to put parentheses around the x minus 1. Let's put it x minus 1. And the reason I'm doing this is I want to change the restrictions a little bit. Restrictions. We know that x minus 1, what's inside, has to be greater than or equal to 0. Or we can say that it can't be less than or equal to 0. Here, this is the first one where x is not by itself. We have to solve it. So we can add 1, telling us that x has to be greater than or equal to 1. X cannot be less than or equal to 1. So x has to be greater than it. Because if x is actually even equal to it, it doesn't work. I don't like that equal to part. Yeah. Has to be greater than it, if we're doing it that way. The way I did it the first time, I know I've changed that at least twice now. Because we could say x minus 1 and do it this way, telling us that x cannot be less than or equal to 1. Essentially, we're trying to see what values can x not be. For this here, if x is less than or equal to 1, it doesn't work. X has to be greater than 1. Does that answer that question? Because the restrictions are more what is going to make it, what's inside the log be 0 or negative. So if it's 1, what's inside is going to be 0. Anything less than 1, so 0 would make it negative. Is all that's saying. Over here, we need to get the log by itself. So we can start off by dividing both sides by 2. Telling us that the natural log of x minus 1 is greater than 2. At this point here, we need to put both sides to the base of. So now we have x minus 1 is greater than e squared. Well, e squared is not a nice number. And the last thing to do to get x by itself is to add 1, telling us x is greater than e to the second plus 1. Well, I'm going to grab the calculator and we can say e to the second plus 1 is 8.389. Well, is, for our test point, is 1 greater than 8.389? No. -8 would also be a restriction. Is -8 greater than this? So are any of our restrictions contained in this solution? No. So that's it. Since the restrictions are values that would be restrictions are not in the solution set we got, don't even have to list it. Because the ones where we had to, restrictions were included. We had to remove them. Here, we don't. Because any value that would be a restriction, so it would be less than or equal to 1, aren't in this. They aren't values that work. So any value that we have for x that is bigger than this 8.389 will not cause the x minus 1 to be negative or 0. So, well, yeah, so this here has to be greater than 0, yes? Well, the first value that would make this be 0 is 1, because 1 minus 1 would be 0. Well, our starting value is this here, so there is no value that makes this statement true. That would cause what's inside the log to be 0 or negative. So we have no restrictions. It's just the solution. Questions on this here? So I'm not going to worry about any of those. That's it.